Hello viewers, in my previous video I have explained the basic terms of applications of trigonometry, and in this session I am going to explain the sums of chapter 9, and today I am starting first sum of 9a. Here the question is, a tower is 100 root 3 meters high. Find the angle of elevation of its top from a point 100 meters away from its foot. Let me first draw the figure, then I will do the sum. As given in the question, a tower is 100 root 3 meter high. So let me draw a tower. Suppose this is a tower whose height is 100 root 3 meter. Okay, and it is given, find the angle of elevation of its top from a point 100 meter away from its foot. So this is the foot of the tower. So suppose this point is at a distance of 100 meters, so this one is 100 meter. This one is the tower, I can write here tower, and this point is the observation point. Let me consider this one as A, this one as B, and this one as C. Let me join this one. As I told you in the previous video, this is called line of sight. Okay, so once I have drawn the figure, I have to describe the figure in short. So I can write here, let AB be a tower. Okay, AB be a tower, and this point is the observation point, and we can write here, and C be the observation. C be the observation point. Clear? Always whenever you draw the figure, since you have drawn the figure, it is your responsibility to explain the figure first. Here BC is how much? Here BC equals to 100 meter. AB is how much? AB equals to 100 root over 3 meter. These two are given in the question, and since it is not given, we can consider this angle to be, say, theta. Let angle ACB equals to theta. Okay, now in the question it is given, find the angle of elevation, and in this figure, since we are viewing from this point, this angle is the angle of elevation, so we have to write to find angle of elevation, and here angle of elevation is theta. Okay, so this is what given in the question, and this is we have to find. Now as you can see in this right angle triangle, this is a right angle because this one is 90 degrees, so this is a right angle. That means the triangle is a right angle triangle. Here base is given, hypotenuse is not given, perpendicular is given, and we know tan theta relates perpendicular and base, so we can write here in solution part, in right triangle ABC, since these two are known, so we can easily calculate theta. So tan theta equals to, turn permanently black we know, so it will be AB by BC. Now tan theta is not known, so you can write tan theta equals to, AB is what? AB is 100 root 3 by 100. Here 100 and 100 cancels, so we are going to get tan theta equals to root 3, and from the knowledge of trigonometric table we know tan 60 is root 3, so we can write here tan of 60 degrees, therefore theta equals to 60 degree. Clear? Don't cancel tan and tan cannot be cancelled. Here since tan theta equal to tan 60, that means angle must be 60 degrees. Therefore we can write angle of elevation. Therefore angle of elevation equals to 60 degrees. That's your answer. In question number 2 it is given, a tower stands vertically on the ground. From a point on the ground 20 meter away from the foot of the tower, the angle of elevation of the top of the tower is 60 degree. What is the height of the tower? So let me first draw the figure, Here it is given a tower stands vertically on the ground. So let me first draw the tower. Suppose this is the tower. Okay, let it be AB is the tower. Okay, and it is given a tower stands vertically on the ground from a point on the ground 20 meter away from the foot of the tower. This is the foot. So at a distance of 20 meters. So this distance is 20 meter from a point on the ground 20 meter away from the foot of the tower. The angle of elevation of the top of the tower is 60 degree. So here this, if I join this one, these 2 points, then this angle will be 60 degrees. What we have to find? We have to find what is the height of the tower. That means we have to find height AB. I think question is clear. Here AB is a tower, and suppose C is the point which is the observation point, and from the C, whenever we view the top of the tower, the angle of elevation is 60 degree. We have to find the height of the tower. Let me now do the sum. Just like previous sum, we have to describe the figure here. Here AB is the tower, so we have to write let AB be the tower and C be the observation point. Observation point, write in full, I am writing in short, observation point. Here BC is how much? Here BC is given as 20 meter. Angle ACB, which I can consider theta, equals to 60 degrees. What we have to find? We have to find the height of the tower. So here you write to find, or you can write required to find height of the tower, height of the tower, that is AB. I hope this much is clear. So once you have drawn the figure, you have to explain the figure, and here we have to find the height of the tower, that is AB is to be calculated. Now while doing this sum, students often face one problem, whether to use sine or cos or tan. For this you have to first see the figure. Here this one you have to calculate. Height of the tower is to be calculated, and this one is given. And what is the trigonometric ratios between this one and this one? Here perpendicular is known, base is known, and we know tan theta relates perpendicular and base. So here we have to use tan theta. Suppose this and this, hypotenuse and base, then you have to use cos theta. And suppose it is hypotenuse and perpendicular, then you have to use sin theta. In my previous video I have explained this one, in which situation which trigonometric ratio you have to use. Here just because base is given and you have to find this, and we know turn permanently black, so that's why I am going to use tan theta here. So in solution part we can write in right triangle ABC, here better to give this symbol because this is right angle. In right triangle ABC, tan 60, we know turn permanently black, that is AB by BC. You write here AB by BC. Tan 60, we know the value of tan 60 is root 3. AB we don't know, and BC here is 20. So if I cross multiply 20 root 3 equal to AB, so I can write AB equals to 20 root over 3, and value of root 3 is, just remember this one, 1.732. In the question, if nothing is given, you can consider 1.73 also. If I consider 1.73, I am going to get 0, 3 to the 6, 7, 34 here. So 34.60. So if nothing is given, you can keep up to this much. And if in the question it is provided, value of root 3 is provided, then use the value and find the height of the tower. So we got 34.60. Therefore, we can write, therefore, height of the tower, therefore height of the tower is how much? Height of the tower is 34.60 meters. I hope this one is clear. Let me explain the next sum now. Question number 3. In question number 3, it is given a vertical pole stands on the level ground from a point on the ground 25 meter away from the foot of the pole. The angle of elevation of its top is found to be 60 degree. Find the height of the pole. as this sum is almost same as the previous sum, here AB is the pole, C is the observation point, because it is given a vertical pole stands on the level ground from a point on the ground 25 meter away. So this distance is 25 meter from the foot of the pole. The angle of elevation is 60 degree. We have to find the height of the pole. That means this AB is to be calculated. So exactly like previous sum, let AB be the pole and C be the observation point. Now BC here it is 25 meter. This angle is 60 degree and we have to find the height of the pole. Here also base is given, perpendicular is to be calculated, and we know we have to use tan theta because turn permanently black. Tan theta relates perpendicular and base, and just because base is given, perpendicular is to be calculated, we have to use tan theta. So tan theta will be AB by BC, AB by BC. Now tan 60 will be AB by 25. Tan 60's value is root 3, AB by 25. So if I cross multiply 25 root 3, so AB equals to 25 root 3. If value of root 3 is provided in the question, you just put the value 1.73, multiply, you are going to get the required answer. So this sum is almost same as previous sum. So let me explain the next sum, that is question number 4. An angle of elevation of a ladder leaning against a wall is 60 degree and the foot of the ladder is 9.5 meter away from the wall. Find the length of the ladder. Let me first draw the figure, then I am going to solve the sum. As given in the question, an angle of elevation of a ladder leaning against a wall is 60 degree. Suppose this is the wall and this is the ladder and this angle is 60 degree. Okay, and the foot of the ladder is 9.5 meter away from the wall. So this is the wall, this is the foot of the ladder. So this distance is 9.5 meter. Clear? This is the wall, this is the ladder, and this angle is 60 degree. This distance is 9.5, and we have to find the length of the ladder. That means this one, this part we have to calculate. Let me name, suppose this point is A, this point is B, and this point is C. That means we have to find AC, which is the length of the ladder. Here AB is the wall, so we can write let AB be the wall and AC be the ladder, which touches the ground at C, because this is the ladder and ladder touches the ground at C. Okay, here BC is how much? BC is given as 9.5 meter. This angle ACB, which we can consider theta, equals to 60 degree given, and we have to find the length of the ladder. That means to find what we have to find? We have to find length of the ladder, that is AC. We can write length of the ladder, which is AC. I hope this much is clear. Now we have to find this one. In this triangle, base is known and we have to calculate hypotenuse. We know whenever it is sin theta relates perpendicular and hypotenuse. Cos theta relates base and hypotenuse, and tan theta relates perpendicular and base. Now out of these three, one I have to use. Here base is given and hypotenuse is to be calculated. So base is given, hypotenuse is to be calculated. That means I have to use here cos theta. So in solution part I am going to write, in right triangle ABC, this angle is 90 degrees, so it is a right angle triangle. We can write cos of 60 degree, we can write here cos theta. We know cos theta is base by hypotenuse, so it will be BC by AC. Now cos of 60, because here it is given angle of elevation is 60, BC is 9.5 and AC is not known. Now what is the value of cos 60? Cos 60 is half. You have to remember the trigonometric table, which I have explained in one of my videos in trigonometry part. by AC. Now if I cross multiply AC into 1, AC equals to 2 into 9.5, it will be 19 meters. Since AC is 19, that means this is the length of the ladder. So we can write therefore length of the ladder, length of the ladder equals to 19 meters. There's the required answer. I hope this one is clear. In question number 5, it is given the string of a kite is 100 meters long and it makes an angle of 60 degree with the horizontal. Find the height of the kite assuming that there is no slack in the string. So here suppose this is the position of the kite and this is the string. Okay, as given in the question, the string of a kite is 100 meters long. That means this one is 100 meters. You can just imagine this one is the kite. Okay, and this is your position. Here you can just consider this line and this line. This angle is 90 degree. This is the kite and this is your position. Let it be C, let this point be B and this point be A. Clear? So it is given the string of a kite is 100 meters long. That means this is the kite, this is the string and this is 100 meters long and it makes an angle of 60 degree. It makes an angle of 60 degree with the horizontal. This is the horizontal line. So this angle is 60 degree. Find the height of the kite. That means we have to find this height. AB is to be calculated assuming that there is no slack in the string. Now after drawing, I have to explain the figure. So here let A be a kite and AC represents the string. Okay, A is the kite and AC is the string and C is the observation point. Let C be the observation point. Whatever figure you have drawn, you have to explain it first. Here AC is given 100 meters, so let me write here AC equals to 100 meter. Angle ACB, which I can consider theta, this one is given 60 degree, this one is 100 meter given, this one 60 degree given, and we have to find height of the kite, that is AB is to be calculated. So we can write here to find, what we have to find? We have to find height of the kite, that is AB is to be calculated. Okay, now in this question hypotenuse is known to us and we have to calculate perpendicular. We know sin theta relates perpendicular and hypotenuse. Here perpendicular is to be calculated, hypotenuse is already given, so we have to use sin theta here. Fine, why we are using sin theta or cos theta or tan theta, that should be clear. Here perpendicular is to be calculated, hypotenuse is given, and perpendicular and hypotenuse, these two are related by sin theta. That's why we are using sin theta here. So in solution part you write in right triangle ABC sin of 60 will be AB by AC. Now sin 60, what's the value of sin 60? Sin 60 is root 3 by 2 equals to AB is not known, AC is 100. So we can, if I cross multiply, it will be 100 root 3 by 2 equals to AB. That means AB equals to 102. If I cancel, I'm going to get 50 root 3. And if in the question it is given the value of root 3, then we have to place the value of root 3, otherwise you can keep this much. Now 50, value of root 3 is 1.73. If I multiply, I'm going to get 86.50. Therefore, the height of the kite is, therefore we can write, therefore height of the kite from the ground is how much? 86.5 meters. That is our answer. Okay, I hope this one is clear. Let me do the next one, that is question number 6 now. In question number 6, it is given the kite is flying at a height of 75 meter from the level ground. A kite is there and it is flying at a height of 75 meter. So that means this height is 75 meter, and suppose this is the position of the kite. Okay, attached to a string inclined at 60 degree to the horizontal. So this is the string, and this string makes an angle of 60 degree with the ground. Okay, find the length of the string. This length is to be calculated assuming that there is no slack in it. That means this sum is almost same as previous sum. In the previous sum, length of the string was given and we have calculated the height of the kite, and here height of the kite is given. We have to calculate length of the string. I hope you can do it yourself. Same sin theta you have to use. If you find any difficulty in doing this sum, you can always text me. Let me do the next sum, that is question number 7. In question number 7, it is given the length of a string between a kite and a point on the ground is 90 meter. If the string makes an angle theta with the ground level such that tan theta equals to root 3, how high is the kite, assuming that there is no slack in the string? Suppose A is the position of the kite and AB is the height of the kite from the ground. AC is the length of the string and C is the observation point. Here length of the string is 90 meter given. This angle is not given, rather it is given tan theta is root 3. What we have to find? We have to find the height of the kite, that is AB we have to calculate. So just like the previous sum, we have to write here, let AB be the height of the kite and AC be its string and C be the observation point. Fine. Here AC is 90, so we have written AC equals to 90 meter. Angle ACB, let it be theta, and here theta is not given directly, rather it is given tan theta equals to root 3. And we have to find the height of the kite. A is the position of the kite, that means AB is the height of the kite from the ground, so height of the kite is AB. Now since theta is not given, first of all we have to find theta from this. We know tan theta equal to root 3, it is given in the question, and root 3 is tan of 60 degree, so tan theta equal to tan 60, which means theta equals to 60. Okay, that means angle we got. Now out of these two, perpendicular is not known, hypotenuse is given. Perpendicular is not known, and we know sin theta equals to, sin theta relates perpendicular and hypotenuse. So here this is perpendicular, this is your hypotenuse. Out of these two, this one is known, this one is not known. So using sin theta, I can calculate AB. That's why you are using sin theta. Okay, so always after drawing the figure, think which trigonometric ratio you are to apply. So here in this right triangle ABC, if I use sin theta, it will be AB by AC. So in right triangle ABC, sin theta is AB by AC. Here theta is how much? 60. So sin 60 will be AB by 90. Sin 60 equals to AB by 90. We know sin 60 is root 3 by 2. AB by 90. This one from the trigonometric table you must know, because in chapter 8 it was there. So AB equals to 90 root 3 by 2. Now 90 root 3 by 2, if I cancel 90 and 2, I am going to get 45. It will be 45 root 3. What is the value of root 3? 1.73. So 45 into 1.73, if I multiply, I am going to get 77.85. Therefore, height of the kite from the ground, that is AB equals to 77.85. Therefore, height of the kite above the ground is 77.85. This sum is almost same as previous sum. Only difference is that here directly angle is not given. We have to calculate angle from this value. Okay, let me explain the next sum, that is question number 8. A 1.5 meter tall boy stands at a distance of 3 meter from the lamppost and casts a shadow of 4.5 meter on the ground. Find the height of the lamppost. Okay, let me first draw the figure. Let this is the lamppost. Suppose this is the lamppost and this is the boy. Height of the boy is 1.5 meter. Okay. Now in the question it is given a 1.5 meter tall boy stands at a distance of 3 meter. This distance is 3 meter from the lamppost and cast a shadow of 4.5 meter on the ground. So this is the boy, this is the lamppost, shadow must be this side. So this is the shadow of the boy, and here it is given this one, this length is 4.5. Okay, this shadow is 4.5 meter. Let me repeat the question. A 1.5 meter tall boy stands at a distance of 3 meter from the lamppost. This is the lamppost, and this boy is casting a shadow of length 4.5 meter. So from here to here it is 4.5 meter on the ground. Find the height of the lamppost. This is the lamppost, and we have to find this height. So we can consider this one to be A, this one to be B, this point suppose it is C, this point we can consider D, and this point E, and suppose this angle is theta. Clear? I hope the question is clear, because this is the most important part of this type of sum, because here figures will not be given to you. After reading the question you have to draw the figure, and if your figure is correct then only sum will be correct. If figure is wrong, definitely your sum will be wrong. Let AB be the lamppost, and EC be the boy. Okay, this is the lamppost and this is the boy. Now distance between lamppost and the boy is 3 meter. Here we can write BC is the distance between boy and the lamppost. And this one is C, this one is D, CD, and CD be the length of the shadow. Length of the shadow formed by the boy. Okay, this part is clear. Now from the figure we have to write the values here. CD is how much? CD equals to 4.5 meter. BC is how much? BC equals to 3 meter. EC is how much? EC equals to 1.5 meter. What we have to find? We have to find length of the lamppost, that is AB is to be calculated. We can write here to find length of the lamppost. You can write height of the lamppost also, same thing. Height of the lamppost, that is AB. I hope this part is clear now. Now one important thing here is that here angle is not given, and without knowing the angle how can you find this one? For this, from this triangle, from the smaller triangle, we have to find theta first, and after calculating theta we can find the height of the lamppost. Clear? So for finding this angle we have to consider triangle ECD. So we can write here in the solution part, in right triangle ECD. Here just see, perpendicular is given, base is given, and we know perpendicular and base, these two are related by tan theta. So I am going to use tan theta here. So here tan theta equals to EC by DC. What is tan theta? Tan theta here it is not known, so let it be tan theta only. EC is 1.5, DC is 4.5 meter. No need to write because it will cancel, it's a ratio. So here unit is meaningless. If I cancel, it will be 1/3. In the trigonometric table that we have done, we have not got this value there. 1/3, this value was not there. So let it be like this. Let it be equation number 1. If I consider the triangle ABD, angle will be theta only. So we can write in right triangle ABD. Again I can use tan theta. Now we are considering ABD. So tan theta will be AB by BD. Tan theta equals to AB by BD. Now why I am using tan theta? Tan theta relates perpendicular and base. Here base is given, perpendicular is not given. So we have to use tan theta. So tan theta is AB by BD. Tan theta we know 1 by 3. So from equation 1 we can use the value 1 by 3. AB is how much? AB is not known. Let it be AB only. And BD will be 4.5 plus 3. So I can write 4.5 plus 3. Clear? Because here BD, it will be BC plus CD. This is 3. This is 4.5. After adding, I am going to get 7.5. So here we can write 1 by 3 equals to AB by 7.5. So if I cross multiply, I am going to get 7.5 equal to thrice AB. Thrice AB equals to 7.5. Therefore, AB equals to 7.5 divided by 3. That will give you 2.5 meters. Therefore, the height of the lamppost, therefore, we can write therefore height of the lamppost equals to 2.5 meters. Okay, that's our answer. I hope this one is clear. So up to 8, question number 8, I think there should not be any confusion. Let me do question number 9 now. A vertically straight tree 15 meter high is broken by wind in such a way that its top just touches the ground and makes an angle of 60 degrees with the ground. At what height from the ground did the tree break? Okay, let me first explain the question, then I am going to solve. Suppose AC is the tree which is 15 meter high. As given in the question, a vertically straight tree 15 meter high is broken by wind in such a way that its top just touches the ground. So suppose at this point it is broken. Suppose this point is B and this AB part will now bend. AB will now shift this way and AB part will come this side. Okay, in such a way that it will strike the ground and it makes an angle of 60 degree. So this part and this part must be equal. It is given at what height from the ground, from this point, at what height from the ground did the tree break? That means this height from B to C, this height we have to calculate. I hope question is clear. Suppose AC is the tree and it is broken at B and AB after bending this point A strike the ground at D. Total height of the tree is given 15 meter. Suppose from B to C this one is X. Then the length of A to B will be 15 minus X because total length is 15. From here to here it is X. So this part will be 15 minus X. Since this is 15 minus X, this also will be 15 minus X. Okay, because AB and BD, these are equal. This angle is 60 degree, it is given in the question. We have to find this length, that is BC. So we have to write like this. Let AC be a tree and the broken part strikes the ground at D by making an angle of 60 degree. Okay, here AC is how much? AC is 15. AC equal to 15 meter. Let BC equals to X meter. This one is not given in the question, so we have considered it to be X. And since this is X, AB equals to BD will be 15 minus X. So AB equals to BD equals to 15 minus X meter. What we have to find? We have to find this length, that is BC. Since perpendicular and hypotenuse are to be related, we have to use sin theta. So here sin 60 will be sin theta equals to BC by BD. So I have written sin 60 equal to BC by BD. Sin 60 is what? Root 3 by 2. What is BC? BC is X and BD is 15 minus X. Now if I cross multiply, root 3 into 15 minus X equal to 2 into X. So 15 root 3 minus root 3 into X equal to twice X. 15 root 3 equal to 2X minus root 3x. If I shift in the other side, it will be plus root 3x. 15 root 3 equals to, from these two I can take x common, we are left with 2 plus root 3. So 15 root 3 divided by 2 plus root 3 is x. Now in class 9 you have done rationalization. So here you have to rationalize. Here it is 2 plus root 3, we have to multiply by 2 minus root 3 both denominator and numerator. 15 root 3 into 2, 2 into 15 30 root 3 plus minus minus 15 root 3 into root 3 3. So 3 into 15 here, and here a plus b, a minus b, a square minus b square. So x equals to 30 root 3, 3 15 is 45, 2 square is 4 and root 3 square is 3. So x equals to 30 root 3 minus 45, because 4 minus 3 is 1. No point in writing this. So x equals to 30 into root 3's value is 1.73 minus 45. If I multiply, I am going to get 51.90 minus 45, which will be 6.9 meter. This height from B to C, this height is 6.9 meter. I hope the sum is clear. This sum is little bit difficult. In question number 10, it is given, in a violent storm, a tree got bent by the wind. The top of the tree meets the ground at an angle of 30 degree at a distance of 30 meters from the root. At what height from the bottom did the tree get bent? What was the original height of the tree? And here value of root 3 is given 1.73. As given in the question, in a violent storm, a tree got bent. Suppose AC is the tree and at point B, it is broken and this part will bend. Now it is given the top of the tree meets the ground at an angle of 30 degree. So this part will now bend this way, and here this angle will be 30 degree. I hope this much is clear. The top of the tree meets the ground at an angle of 30 degree at a distance of 30 meters from the root. This is the root of the tree, so this distance is 30 meters. At what height from the bottom did the tree get bent? So we have to calculate this height, that is BC is to be calculated. What was the original height of the tree? AC also we have to calculate. I hope question is clear. Now I am going to solve it. Let this part be x, this part be y, and since this is y, this also will be y. Okay, here angle is 30, this distance is 30 meter. So since AC is representing the tree, we can write here, this is question number 10, let AC represents a tree which broke at B and the top touches the ground at, suppose ABC, this one is D, at D by making an angle of 30 degree. This angle is 30 degree. With the horizontal you can write with the ground. Okay, now here CD is how much? CD equals to 30 meters. Let BC equals to x meter. AB equals to BD, we can consider y meter. Okay, so here two things we have to find. At what height from the bottom did the tree get bent? That means BC we have to calculate. So here we can write to find we have to calculate two things here. First one, this length, that is BC, and second the height of the tree, that is AC. Here you can write BC, that means x you have to calculate, and here x plus y. Okay, now for this, in this triangle base is known but perpendicular is not known, and we know relation between perpendicular and base is tan theta. So by using tan theta we can calculate this x. So let me first use tan theta to calculate x. So you can write the solution part. In right triangle BCD, tan 30 will be BC by CD. You can write here BC by CD. What is the value of tan 30? Tan 30 is 1 by root over 3 equals to BC is x by 30. This is x, this one is 30. So if I cross multiply, I'm going to get x root 3x equals to 30. Therefore, x equals to 30 divided by root 3. 30 divided by root 3. Now, since here root 3 in the denominator, we have to rationalize 30 root 3. You multiply by root 3. So, it will be 30 root 3. And here, root 3 into root 3, 3, 10. So, it will be 10 into root 3. And root 3's value is given as 1.73. Therefore, this one is 17.3 meter. Okay, so we got x equals to, therefore x equals to 17.3 meter. Let it be equation number 1. So already we got x. Now we want y. Now we know this one and this one same. So in this triangle, now base is known, hypotenuse is not known, and we can relate these two by cos theta. So by using cos theta, I am going to calculate y now. So we can write here, in right triangle BCD, cos of 30 will be CD by BD. Just see here, cos theta will be, cos of 30 will be base by hypotenuse. Base is 30, CD by BD, that is 30 by y. Okay, in this triangle, cos theta we are using because this part is given, this part is to be calculated. Cos 30's value is root 3 by 2 equals to CD. CD is given in the question 30 and this one is y. So if I cross multiply, root 3y equal to 32 ja 60. So y equals to 60 divided by root 3. If I rationalize, it will be 60 root 3. We have to multiply by root 3 again. It will be 60 root 3 by 3, 20 root 3. Now root 3's value we know it is 1.73. If I multiply, I am going to get 34.6 meter. Okay, so this is y. This is equation 2. Now we have to find two things. One is x, another is x plus y. Therefore, height of the tree, that is AC, equals to x plus y. X we got 17.3 and here we got 34.6. If I add, I'm going to get 9 here, 51.9 meters. Okay, therefore two things. First is the first part of the question, it is given that at what height from the bottom did the tree break or bend. The tree broke at a height of, here x how much we got, 17.3, at a height of 17.3 meter from ground. Okay, this is the first part. And second part, total height of the tree, equals to, we got 51.9. So these are the two answers, 51.9 meter. So this is our required answer. I hope this one is clear, and that's all for today because there are many more sums. So in my next video I am going to solve the remaining sums. Till then, bye bye, take care and wait for the next video.